All right, so this video is an additional practice with some things from chapter 6, and this is number 52 in chapter 6. And you can read about it in the chapter, but yeah, basically we're trying to find the coefficient of kinetic friction. The picture is that we're pulling the sled, a 60 kilogram sled, and we're pulling it up. So it's moving at a constant velocity. So they say V is 1.5 meters per second, but A is 0. That's going to activate Newton's first law. So this will be an F net equals 0 situation. And we're given an angle of 30 degrees, and we're pulling on some rope, with a force of 75 newtons. And so the question is, find mu. So what's free body diagram look like? We've got, well, let's do X and Y as our standard X and Y coordinates. Okay, we've obviously got a downward force downward gravity force, mg. Now, what's the rest of this stuff look like? We have an upward pull. We call this pull or maybe tension T or something like that. Now, a normal force, that normal force is going to be smaller than mg because there's an upward tension, and that smaller normal force will give us a friction force. Yeah, will give us a friction force that points backwards. And we've got that F net is 0. Okay. There we go. Okay. So in fashion of the previous examples, the one thing that we're missing is that F net equals 0. It's helpful to outline that out. Okay. And we know that this is angle theta, so that's our free body diagram. So now what we want to do is take that free body diagram and sum the forces in each direction. So let's do the X direction and the Y direction. We'll actually need both of them, because what we're trying to do, if you write as the book encourages us to do so, we write down all our knowns. We have a mass, and these are the numbers in the textbook, a mass of 60 kilograms, a tension of 75 newtons, an angle theta of 30 degrees, and we're trying to find mu sub k. So finding mu sub k results that we need to know the friction force and the normal force. And so those are the ones that we technically don't know. So let's go through that and figure that out. So summing in the X direction, both of these have to add to 0 since our acceleration is 0. So let's take a look. This will be in the X direction. We're going to have T cosine 30. So plus T cosine 30, which we know, 75, cosine 30 minus F sub k, 0. And then what about in the Y direction? This would be plus N plus T sine of 30. And that's minus mg equals 0. Okay, so several different pieces in this example. One, of course, being able to identify different forces, and then also being able to write them on a free body diagram, and then also being able to sum them, and then algebraically. So how do we find the friction force in this example? It's pretty straightforward. The friction force is just equal to, in these numbers, it's 75 newtons times cosine of 30 degrees. Cosine of 30 degrees is radical 3/2. So it's 75 times 0.86, which probably be about 65 or so. 65 newtons. Yeah, 7.5. 7.5 times 8 is 59.5. Okay, yeah, right. So it's okay, so it's a little off that. And then the normal force that's the easier one. So the normal force, it should be much bigger because coefficients are usually smaller. So the normal force is going to be equal to T sine of 30 plus mg. So T is 75, so sine of 30 is a half. So this is 37.5 newtons. 60 kilograms times 9.8 is 588 newtons. And so that sums to, let's see, 628 minus 2.5, so 626 point, oops, 620, geez, 620, there you go, 5.5 newtons. And so you should get, based on what we found, it looks to me like you're going to get a coefficient of friction, which is equal to the friction force divided by the normal force. You can figure it out for yourself, but it should be around 0.1, which is expected for snow. I mean, you look at cross-country skiers. I mean, cross-country skiers are able to maintain a pretty large constant velocity on flat snow because of this small coefficient of friction. So this is one example. Another example of chapter 6, where we're dealing with different forces and you're having to find something in the problem based on what you're given. All of the techniques are present, free body diagrams, summing the forces, and then ultimately algebraically solving for the thing that you need. So that is it for this problem.